Expo. We have a very interesting panel here talking about, we see, propulsion systems, and we try to talk about all aspects of future propulsion systems, which are battery-powered propulsion system, the motor, which is propeller, and which is use cases. So stay tuned. We have a little bit more time, but we also have 6 speakers. So I think we should get started. Just a quick background. If you have to leave to some other meeting, what we are recording this session and you can watch it on our YouTube channel after the show. So if you have to leave, you don't miss anything. Second thing is we are publishing the magazine, eFly Journal, where we will cover also all the companies on the panels here. So with this, I don't want to use too much of the time. I get to my first speaker, Alexander Ablev from V4 Smart. Maybe he also tells us how they come to the name V4 Smart, because I was wondering about this. So Alexander, stage is yours. I give you the panel, and one thing, if you have questions, we talk one after the other, and then we have questions in the end when we have the panel. Thank you very much.
Thank you. So before I will start, I will introduce myself. So my name is Alexander Abel. I'm responsible for the product management within V4 Smart. So before I want to start, I want to give you some background. So at the moment, 90% of lithium-ion battery cells are not, which are used in Europe, are not coming from Europe, and 80% of the battery cells which are used in Europe are coming from Asia. This is where V4 Smart is coming into the game. V4 Smart is a manufacturer of lithium-ion battery round cells, and the unique part here is that we are doing that completely in Germany. So we are doing the full design, the development process, and also the manufacturing in Germany. So a little bit about the background and also about the naming of V4 Smart. V4 Smart was a part of the Varta AG group, so it was one of 6 business units within Varta, which is a well-known German battery manufacturing company. And this business field was completely separated into a new legal entity, which is called V4 Smart, and this is now operating on the market as a joint venture between Porsche and Varta. So the major shareholder is Porsche, the minor shareholder is Varta, and the company is operating on the market since 1 year now. About the name, so the V is coming from Varta and the Smart is coming from Porsche. It was formerly known as V4 Drive, but we want to be more open for other applications, especially also in the aerospace field. Therefore, we decided to change the name and be more open to third-party applications out of automotive. So what is in the company? The company includes roughly 450 employees, all the patents, all the production sites, all the R&D related topics are now in the new legal entity. And we have 2 production sites. On the left side you can see the headquarters of Varta, and which we have also our R&D facilities. And on the right hand side you can see our production site in Bavaria, Nördlingen, where we are really be able to produce 22 million battery cells per year, and this is quite unique. At the moment we are the only company which is doing lithium-ion cylindrical round cells in Europe in mass production scale. We're delivering those battery cells into automotive. So one of our customers is Porsche, and it's going into the 911 into series. So this is quite special here. What is unique in the cell, or what makes the cell special? We are focusing really on high performance cells. Our first generation cell is an ultra high power cell, so this means a lot of energy can go out in a very short period of time. So this is quite unique. We have a very, very low internal resistance. We have an advanced mechanical design. and this is our USP in technology, in the technology field. To make that happen, we have also a very, very advanced process technology. One of the key advantages here is our laser welding process. So we are able to do a laser welding into metal with a distance of 0.5 millimeters to the separator, and this is everyone which is in battery cell or in the field of battery understand that this is quite critical and quite heavy to do. So this is so we are very strong in the industrialization and in the process in mass production, which allows us to make such high-end battery cells happen in a larger scale. On the next chart here you can see a screenshot of a chart which is called the Batemo chart. Batemo is a German institute which is doing benchmarking of different battery cells which are available on the market. All the blue and light green bottles which you can see on the left hand side are cells which are available on the market, and the green cell on the right hand side is our first generation UHP26 cell, which is in mass production, which is in the car, in the Porsche 911, and you can see it's really unique in terms of the power density. So we have more than 8,500 watts per liter in those kind of cells, which is, in my point of view, really impressive. What is the future about? What are we're working in the future on? We have two pathways here. On the one hand, we have a cell which is more going into the high energy direction. So this is the yellow pathway, and then we have a next generation of the UHP cell, which is 75% increasing the energy density and is moving the energy density from 8,500 watts per liter to 50,000 watts per liter, which is really crazy in my point of view. So we have here 300 ampere hours, 300 amps, 300 amps. I will come to that later. Then you can see here the applications which we are addressing in the first generation. We are really coming from the hybrid vehicles, the sports cars. So we are out of automotive. This was the first direction, but based on the learnings and the process readiness which we have and the load tolerances which we can achieve, we are thinking that we are also very capable to go into markets like aerospace or space applications, especially with the generation 2, which is on the one hand increasing the energy density with the 5.x ampere hour cell, but on the other hand, which is increasing the power density with our UHP 3X cell. So this is the reason why we want to open our target markets in the future more in the direction of aerospace and space applications. A moment. So moving. So now this is what I already told you. So we are coming from the sports car and fuel cell applications, and we want to go into drones and aerospace in the future. We see that the safety standards are sometimes comparable, long ranges are necessary, and also the high performance is necessary. So high performance in terms of high C rates, performance under rough conditions. So then I want to tell you more about the next generation of our products. So as already explained, we have the HP5X, which is going more into energy density direction. So here we have a cell with roughly 300 watt hours per kilogram, but also 50 amperes continuous discharging current, which is quite special for a round cell. And then on the other hand, we have the UHP 3X cell, with a capacity from more than 3.4 ampere hours per cell, but more than 300 ampere hour peak current, which can be discharged, which is quite special here. So here we have also, I only want to make a quick give you a quick overview here. The key takeaway of that chart is on the left-hand side, you can see our current generation, the UHP26 cell, which is really able to operate under rough conditions. So the cell delivers roughly 50 ampere hours by minus 25 degrees. And on the right-hand side, you can see the next generation of the UHP cell, so the UHP3X cell, which is delivering up to 20 amperes by minus 40 degrees. So this allows really a broad range of operations and also applications. And I think that's quite special in terms of lithium-ion battery cells. Yeah. I think this is only give you also an overview about the safety standards which we are addressing. So it shows more or less that there will be no damages or mechanical changes over the lifetime, especially when the cell is used by more than 130 degrees Celsius. In summary, what is the takeaway? So we are a German-based lithium-ion battery cell manufacturer, which is quite special. We're doing specialized cells in terms of power, but also in terms of thermal behavior and application fields, which is addressing rough conditions. And we are open for aerospace, so we are coming from the high-end automotive, and we want to go in the high-end aerospace and space sector. Thank you very much.
Thank you very much, and sorry for rushing you so much, but we have so many interesting topics that we think we give you a glimpse and then you will follow up. Our next speaker, like we always try to be really international, is from United States. David, if you come to say, they're working for quite a while on hybrid systems. As a lot of people say right now, if you talk with the airframe manufacturers, they say yes, electric is fine, battery is not enough for what we want to do for our use case. That's why we have to have hybrids. And David, they're working on it at Vertigo.
Thank you, Willie. Okay, let's get this working. Very good. Okay, so I'm David Eichstead, VP of Product Management at Vertigo Aero. We are a startup who's been in business since 2017. We're located in Daytona Beach, Florida. We have about 35 employees. And we're in the research park that's affiliated with Embry-Riddle Aeronautical University. Green one. That one. That green one. Okay, very good. So what we've seen 10 years ago or so, electricity has kind of been seen more as auxiliary power on aircraft for powering avionics and lighting systems and things like that. And what we are seeing more and more, electricity is becoming more of a primary power element for the aircraft. And certainly that's true for aircraft that are electric powered, but that's also becoming true for conventionally powered aircraft that have significant power needs on board. That's happening across the board, but especially in defense applications. So we believe that hybrid electric systems are really a great way of being able to provide all that additional electric power that's required on board the aircraft. So our business model is, as I said, we're focused on hybrid electric power plants. We are not an engine company. We do not develop engines. Those require huge dollar investments, time investments, certification investments. So we prefer to focus on using engines that already exist, that are already certified or on a certification path. Around those existing engines, we will wrap our own technologies to turn those engines into hybrid power plants. So you can burn liquid fuel to generate electricity. Our focus is on jet fuel and SAF. We tend to stay away from gasoline-powered systems. So we have engine partners. We develop the hybrid power plant around them. So then our customers are the aircraft manufacturers. who then integrate our system into the aircraft. We do a lot of work with our customers to assist them in that integration process. And of course, then the aircraft operators are the ones who get the benefits of what hybrid power can provide, which compared to battery electric aircraft is primarily extended range and endurance and compatibility with existing refueling infrastructure. So when we look at an electrified aircraft, the powertrain, we divide the powertrain into two halves. There's the upstream, which is where the power comes from or where the energy is stored and then released. So those are hybrid power plants, turbogenerators, their battery systems, their fuel cells. On the downstream side is everything that consumes the power. So it could be a single electric motor, it could be an array of electric motors like Volocopter here, or the onboard mission systems again that are requiring more and more elements of electric power. So Vertigo participates only on the upstream end. We also are not developing our own battery packs. Every airframe developer seems to have their own concept of what a battery pack should be, and so we prefer to be able to integrate and cooperate, coordinate with those who are developing their own batteries. So we have three primary power plant architectures that we are working on. The first one is our piston hybrid architecture, which the latest version is the VH3. The VH3, it's built around an SMA SR305 engine, so it's a German engine. And it's a little bit lower on the power density, but the specific fuel consumption is wonderful. The efficiency is amazing on this one. And the first example of that engine is going to be running probably in about the next 2 weeks or so. So we consider our piston hybrid architecture to be at TRL7. Previous version, the VH2, is already in manned flight test. Second architecture is turbine hybrid, which is the VH4T shown here. This system is it's very popular. It's much higher power density, so therefore higher performance. Puts out around 400 kilowatts, which is about 550 horsepower. This system is at TRL6. We've got a couple hundred hours of runtime on this one. We also have the latest version of this on display over in our booth, our stand over number A110, over up against the wall if you want to come by and see what that looks like. Our third architecture we call the VH5 blended turbofan. This is a unique convertible engine that can enable a single turbine core to develop electric power for electric powered vertical flight modes, or direct turbofan thrust for high speed forward cruise. Or you can blend between those two, a combination of electricity and direct turbofan thrust. That's a much lower TRL, maybe TRL 2 or 3. But all of our systems are dual use, so they're all applicable for both defense and commercial applications. So recently, just to give some company updates here, recently we went back and totaled up how many run hours we have on our systems, and across all of them, we're now over 1,200 hours of runtime. Approximately half of those hours are with power plants that are operated by our customers. And then previously I mentioned our VH2 system being in manned flight test. We now have over 160 hours of runtime in the air with people on board. We have multiple of the first version, the prototype version of the VH4T called the VH4T RD. We have multiple of those completed now at this point, and we've delivered recently the first one to a customer, so that's an exciting milestone for us. In that center picture you can see the assembly bay with the 2 completed power plants and then 2 more engines in the background being ready to go into assembly. As I said earlier, you can see the VH4T 415 mock-up there in the lower right corner. With that product, we've already begun FAA Part 33 certification, which we're expecting to complete around the end of 2029. So when we look back at what we've done, we've realized Vertigo, since we've started, Our team has developed 6 different hybrid power plants, with 2 more coming online this year. So that's a good deal of experience, practical experience in creating electricity. We're on a good path for certification. Our systems are available now. We can deliver a VH4T on about a 9-month lead time, which is very useful for getting into early Copperbird testing, Ironbird testing, or initial flight tests of unmanned aircraft. So we really see commercial interest is accelerating in hybrid power plants, and we think we're in a really good position to help drive that forward with the various offerings that we have. So that's what I have for today, and I'll hand it over to Willie for the next speaker.
Thank you very much, David. And yes, we try to speak about the whole powertrain. And the powertrain exists on now when we talk about batteries, maybe fuel cell, then we have the motors, maybe a combustion engine. But how do we get the power into the air? For this we need propellers. And propellers, mainly, sometimes ducted fans, but mainly it's propellers in electric aviation. And the thing with propellers is, in the beginning everybody thought I just take any propeller, put it on and it will work. Mitch from Hartzell Propeller can tell us it's much more difficult. So Mitch, come up to stage.
Thanks, Willie. Hello, everyone. All right, green button up top, right, guys? Is this what it is? All right, so Mitch Heaton is my name. I'm from Hartzell Propeller, been there about 4.5 years, and let me know if I'm cue. All right, perfect. So a little bit about me, just briefly. The Hartzell team brought me in to work within the advanced air mobility space, and that's what I did straight away. Got a chance to kind of develop our strategy as a company towards all of the different new aircraft that were coming online, and figuring out what kind of technology we needed to advance to be able to be ready for this ever-growing and quickly growing market. So, okay, all right. So I want to make sure I mention to you all the different brands that are part of our portfolio. Hartzell Propeller, been around 107 years. But then additionally, Whirlwind Propeller we acquired a couple years ago for the ability of not only rapid prototyping, but for an existing brand that had been around for about 25 years. It's primarily experimental propellers, but they also have airboat propellers and a lot of other different offerings. So we acquired them about 2.5 years ago. And then in the preheat side, preconditioning systems for both helicopters and traditional aircraft, avionics, batteries, engines, all the preheat systems that go along. That is 2 acquisitions of Tannis and Rife. Now, those names all may be familiar to some of you. What's not familiar is the Hartzell Global Services. And so as we continue to grow and as we have become a global footprint company for so long, our Hartzell Global Services allows for that safety and support throughout the entire globe in an efficient turnaround time, efficient process, and then, of course, guidance towards costs that you're looking for to be able to predict maintenance schedules. Also, this 107 years allows us to have all of these different brands. The reason why people partner with us from the very beginning is because what you see in the top right. We are able to design with you, develop the product and test, get through certification, and I'll show you in a slide in a second that we're an ODA with the FAA. We go through production and all the way to the support, as I mentioned, with Hartzell Global Services. But all of these companies have asked us to build a propeller for them on the line during production when they first deliver their aircraft to their customers. So it's a great list, and this concludes both us and some of our sister companies within the Signia portfolio. So years past, looking towards what we continue to do. Recently, Signia Aerospace, part of the ARC line fund of companies, made an acquisition of us 2.5 years ago. And since then, they've allowed us to really, I'll say, how many people have a to-do list right now, right? They allowed us to take what was on the to-do list to done. right? We needed to advance those things that we wanted to do for a very long time. So we've invested in our portfolio, we've invested in new products, our advanced air mobility side, technology, facilities, all of that, which I'll briefly go through here in the next couple slides. Big thing is we always hang our hat on, first is on our actual logo, built on honor, and we stand behind that with quality, performance, and support. So that theme will be a part of all the different slides here. So first, briefly in the top prop portfolio, and then I'll get over to the advanced air mobility side. We've added 150 new propellers into our top prop portfolio. For those that don't know, those are mostly STC programs. But what it shows is that we can take an existing aircraft, an existing engine, a new engine, whatever it is, and work alongside you to be able to develop that solution for your aircraft, your company, your hybrid portfolio, whatever it is, and make it work for that. What we've done here is we have 700 different products that have advanced into different prop stages, and some of those we're supporting from the 1960s still, actually even the 40s technically. So this is just showing you that we've continued to invest in additional aspects and offerings for you. But then, specific to new products, we have the ability to design from the very beginning with you. So that's why people come to us. That's why people work with us, is that this official designation authority from, we don't have to have a DER. We don't have to have any of those different people that are working with externally. Directly with the FDA, we get through that, and then that allows for us to file those validations across the world in other locations. So I really touch on this, is that we can develop new products right away and get through them quicker because of this ODA. So here's a snapshot of a lot of the propellers that have been developed over the last year and a half. You've got anything from King Airs to Mooney Anomalies, Game Birds, and then of course the Cub Crafters that you can see just one haul over our newest product line, the Falcon product line that's just come out for Rotax market. And as I mentioned there, I've been stolen. So I'm going to skip ahead just to make sure that everybody else has their time. The AAM market, right? Advanced Air Mobility. We already had constant speed. We developed everything towards a mission of constant speed and certifiability. But that has to adjust, as Willie said, to these different power plants. Additionally, we've had ground adjustable propellers, but we haven't made them in 60 years for any type of frequency. We reintroduced that with Beta, which I'll talk to you about in a second. And then on down the list, I'll give you examples over the next several slides. But you can see that it takes a lot to be able to adjust to a new market. So, disclaimer, you'll see a lot of people that we've worked with, some people that we have worked with deeply, but not necessarily announced. I'm not trying to ruin any new affiliations, but just want to give you that full background. So this is the coup d'etat from the beginning, right? This project, we did develop the ground adjustable propeller for them, for their power plant, the H500, and we were able to certify this, the first fully certified propeller for an electric aircraft. Big deal. It's in the process within EASA as well now, and has experimented first with 3 different propellers, worked through it, found the solution, and now Beta is flying and loves it. It's become a tremendous partnership for us, not only, of course, in North America, but around the globe. So what that's done is they've asked us for more AAM designs. So what are those kind of designs between them and others? Some of the things I'm going to talk about here. So Beta, of course, and then projects like MagniX. MagniX we've partnered with and developed not only our propeller but control systems as well. So it's a constant speed, but we needed to do additional projects within. So Harbor Air was the first to test that and continues to have, I think, 1,000 different test flights that they've continued to advance. Eviation, 2 propellers, both constant speed, required a whole set of different control systems, what we call our propeller control units. Those, whether it be a governor or a full PCU that houses the governor, we had to adapt towards what their requirements were. And so ultimately, every project requires something a little bit different. Universal hydrogen, we tested the prop, also needed a different set of controls, needed different governors. Spinners had to align, but we were trying to show that we could make it on an aircraft of this size, and they needed to prove out the hydrogen itself. Unfortunately, both of those two companies no longer exist, but those taught us a lot in the early stages of how to be ready for additional aircraft as well. Of course, Whisk, the tilt rotors, the lifters, fixed pitch lifters are something that we've not had to do, but we can do now. We've developed it for people like Whisk and others to be able to say, hey, we have these possibilities for you, and now we've prototyped that and can replicate it over and over. The tilt rotor is the toughest thing. Tilt rotor becomes when you lift and then you turn forward, those are stresses on propellers that most aircraft have not seen. We bird strike that, we lightning strike, we do everything that we can, and we've made it past to make sure that we're comfortable in designs like this one. As you can see with this, it looks very similar to Archers, kind of in line with Joby. For those that understand the different formats, tilt rotors were key. That's why I'm showing this slide for those two different possibilities. And then Dovetail with the full control system, Dovetail doing the electric aviation, we had to match up, and you can see them here today as well with our propeller, our controls, our governor, and all of the likes. So that required a whole different setup for a Cessna refit, retrofit, and it's gone extremely well. We announced that last year at the Paris Air Show. What's next? We also have to do hollow blades. That's not something novel, but it is for us in order to continue to decrease weight, which everybody wants. I've heard every ounce you get rid of is worth $8,000 on the aircraft. So if I give more than that for this, everybody give me $8,000. That's what I'm looking for. So we continue. I just wanted to show you the scope and the size, but things that we continue to do innovation-wise. And then lastly, second to last, smaller propellers, like what I talked about with the Rotax size. Rotax 912, 914, 916. The newest propeller it is the Falcon series that works along with the 916, and it's the lightest weight on the market that's in a full constant speed offering. Okay, so it's sub 20 pounds as the propeller itself, and once you add the spinner and hub extensions, it usually fits right around 21 pounds total, which ends up being 10.5 kilograms. So lightest on the market for full constant speed, outperforming the market, and then that just allows us to be able to work with smaller aircraft, smaller engines, and then all of the different possibilities within AAM. Last thing, if you're in a cold environment, you're parking at night, you have to have everything be ready to start on a cold start and not damage your engine. Not damage your gearbox, your shore power, your avionics and cabin heaters. All of those things need to be secure in the event of a sub 40 degrees. Anything along those lines, you want to make sure that it's ready to go. So that's why we acquired the Tannis products, and that is in our portfolio as well. That aligns with hybrid just as much as it does a traditional engine, and just as much as it does with electric engines too. So all of these different portfolio items we've continued to add or advance to be a part of the advanced air mobility world, which is why Willie was kind enough to ask us to talk. So that's my time.
Thank you. And very interesting stuff. I already have several questions, you probably too, when we come to the Q&A. Our next speakers, again, a different scope of the AAM mobility. It's a company who developed from the scratch a new diesel jet fuel motor, 12 cylinders, comparable power with a turbine, and when they see AAM moving forward, they also thought, okay, people are asking for a power unit with electric power generation. They have it now, and Christian Mundikler is going to tell us about it.
Good morning, ladies and gentlemen, two ladies. My name is Christian Mundigler. On behalf of Red Aircraft, I'm pleased to talk about our hybrid generator units, customers up to 380 kilowatt, and we are honored to be nominated for the Sustainable Aviation Award. Let's see who is winning the prize in the afternoon today. So Red Aircraft was briefly announced by Willy. Red is already existing since 30 years, but in aviation since 2008. And I show this slide because we always get asked if we are certified. Yes, our engines are certified in 2014, the 500 horsepower version, and in 2018, the aerobatic version. And since 2022, we have the 550 horsepower extension. And since 2024, we also have a site in the States, in Redmond, Oregon, a so-called STC house. The base of our hybrid unit is the well-known and certified A03 engine version in different categories, from utility to aerobatic and high altitude and helicopter. So we are using the helicopter version, the Dash 300 for the hybrid generator unit or APU, whatever you call it. I want to mention explicitly that this is not the car engine, this is an aviation engine from scratch, designed originally from Formula One Toyota team members back in the days of 2008. And it's a highly integrated engine, and so far we have already experience in parallel hybrid, but also in serial hybrid project, and we want to target, of course, the eVTOL business and the electric aircraft business for range extender. So the FADEC is a unique golden nugget, I would say, because it was developed in-house and the IP is owned by Red Aircraft. So we are completely independent. We have a big software team, and so we are flexible. It's DAL B certified and even foreseen for CS29 big helicopters. This, I think, already tells you the safety level and redundancy. Coming to the generator unit itself, thanks to our partner Helix, George Potter came from UK, Extra, is supporting us here in this and other projects. Very reliable partner and supportive partner from UK, together with Zirkler, a sister company of Helix in Austria, delivering the planetary gearbox. So what we are targeting, I already told you, and that we are based on the certified engine, I also told you already. So we are doing customization. So this means we're doing what the customer wants, either with gearbox or without gearbox. And we can put up to 3 generators on one shaft when it's direct draft. And when it comes to gearbox, with a planetary gearbox, for example, 5.4 gear ratio from Zirkler, up to 22,000 RPM. And you can see the dimensions, how it looks like with this customized Helix generator 177. I don't say more because it's customized for us, it's from Helix. And it's producing even more than the 380 kilowatt, but our engine delivers only 405 kilowatts still, maybe in the future more. So 383 kilowatt for 5 minutes, generated out of the 405 kilowatt from the ICE in integrated combustion engine at 4,000 RPM, and max continuous power is close to 330 kilowatt, 327, as you can see at crankshaft speed 3,750. And what is unique, so here's also the number, I heard already low specific fuel consumption. In the optimum, our engine has 218 gram per kilowatt hour, which is also leading in the industry, I would say. So you see some examples to make it short. Max continuous power 77 kilogram per hour. Yeah, and compared to turbine, nearly half, I would say. And we have it also in high altitude version. Especially when it comes to APU, you need to go up to 41,000 feet and higher. So with our high altitude version, we can go up to flight level 500. So you see the two power lines with the standard and the high altitude version. weight, 350 kilogram dry weight, meaning 290 kilogram from the engine itself, and 60 kilogram for the generator from Helix with 21 kilogram, 2 times inverters, each 10 kilogram, and the gearbox 19 kilogram from Circular, and some cooling stuff for the hybrid control unit. So we deliver package ready to generate with all the electric looms, FADEC of course, exhaust system, turbochargers, self-explaining generators and inverters, and the integrated cooling system for the electric part. And optionally, we also deliver the installation kit. So the customer can order either the generator unit itself or the complete unit with the installation as well, or can source the radiators, intercoolers, whatever, locally. So the advantage compared to a turbine is for sure the fuel burn. I already mentioned nearly half, and correlating the CO2 emission, of course, and noise. Noise is becoming more and more, also for APU applications, becoming relevant in the future. Zurich Airport, for example, close here, does not allow to switch on the APU on ground. You have to plug in and you have to pay at the airport. And if you land in the cities with the eVTOL generating, noise is also an issue. So we stay below 75 decibel in 20 meter. So lower purchase cost, of course, compared to a turbine, lower maintenance cost, and in total lower operating cost. We are a design organization. We want to sell engines, spare part, hybrid generator units, but also engineering work. And we offer our customers as a one-stop shop to do joint development, supplier selection, engineering testing, compliance showing, and also documentation. So we are a design organization and are also selling engineering work power by the hour. We're providing 3D data to accelerate the integration of the engine, of the generator, inverter, whatever. And in a nutshell, Red Aircraft is developing hybrid generator units customized according to the customer needs, fast and flexible. And we are in close contact with major manufacturers in the generator world and inverter world, but we found Helix to be the most supportive and fastest in delivering when it comes to delivery. So in the future we have also foreseen downsizing from the V12 to the V8, i6 and i4, coming down to 140 kilowatt on the electric side. So other come up from down to top level, and we go from top level down to 140 kilowatt. So here's some pictures of existing STC conversion from air tractor that will be ready in July, and then displayed in Oshkosh this year at AirVenture. Fletcher in New Zealand will also be ready by end of the year with their STC. Here a commuter, well known, the Beaver, the Havilland 2, that is flying again soon and completing STC this year as well. Potential of 1,000 aircraft to be converted. And this is also well known, this project, Celera 500 from Otto Aviation, using the high altitude version. And most exciting now, Ampere flying around 10 hours per week currently to complete the STC by mid of next year. This is the target. They also have interesting numbers, but they will announce their own press release in 2 weeks from now. I don't want to tell too much here. A new customer is Malloy Aircraft for the trainer application, which is unique. Their USP is to train commercial aircraft pilots in half of the time, 18 months, half of the cost, $750,000 on the same platform, the Blue Jay MA1. And also well-known project, this is continuing again, the Airlander 10 from Hybrid Air Vehicle in UK. And we are allowed to mention their claim, 75% fewer emission compared to comparable aircraft with 130 passengers on the same route. So this is their claim, not ours, but we are allowed to mention it. Thanks for your attention, and I'm ready for the questions.
Thank you. Thank you, Christian. And we will see, as I saw, there are more and more of the large eVTOL manufacturers thinking on hybrid. Maybe this is a solution, because if you go into passenger transport, you always have to go with certified engines, motors, turbines, and this is one of the few options, is this high power range. Our next speaker, we've been at propellers, at motors. Now we are at a manufacturer, Emosys from Germany. It's also, I think it's fairly new. Peter Balcevic. He will tell us what they are doing. I think you're connected with a large manufacturer, MTU. So it's not new for the aviation world, but in the electric propulsion systems, they are fairly new. They've been at the show 3 times. Let's see what is new. Thank you.
Yeah, thank you. Hello everyone, and I'm pleased to be here. My name is Peter Blažević from Emosys. I'm the sales manager at Emosys, and want to briefly introduce about Emosys and our approach to electric propulsion systems for electric aviation. Yeah, we have 2 core technologies. First, our innovative electric motors, and second one is our highly integrated power electronics. And by combining both in a single system, we achieve extreme high power density and efficiency. We are working in 3 business sectors. The main or the important one for us is the aviation sector, but we also have customers from the automotive and from the industry sector. We are located in the near of Munich, and it is Starnberg, Lake of Starnberg, and MTU Aero Engine, as our parent company, is located in the north of Munich, and for this we are not so far away, and this cooperation gives us a strong foundation because MTU Aero Engines has a lot of experience in the aviation industry, and for us this is a really good benefit. Yeah, our core strength is the end-to-end capability. We handle the entire development process from the beginning. That means from the customer ideas, from the first request from the customer, up to the prototyping, and also we do a small serial production. And I would say a great benefit is that we have, as said before, with MTU Aero Engines, we have the competitive for the certification. At Emosys we have 3, I would say, core technology lines. On the left side it is called boost drive air. This is an actuator with an extreme high acceleration and also with a torque of 40 Newton meters. And the housing is similar to two smartphones. In the middle we see our boost drive speed. This is a smaller electric motor with an integrated inverter. And the power is from 10 kilowatt up to 350 kilowatts. And on the right side is our high power machine. It starts from 200 kilowatts up to 2 megawatts. So always the inverter is fully integrated. And these are some key figures or key performance indicators of our products. For example, with our actuator, we reach the acceleration from 0 to 100 RPM in just 0.2 milliseconds, and this is really fast. We achieve a power density up to 15 kilowatt per kilogram and more, and we achieve also efficiency up to 98%. On this slide, I want to show you, this is a real test bench run of our 600 kilowatt motor and inverter. And as we see on the right side, in the field of the continuous power, so we are talking about 500 up till 600 kilowatts, we achieve 98% efficiency. That means from the start, from the DC input to the shaft, we only lose 2% of energy. This is just an example of our long-term project. It is called IFFC. It's a flying fuel cell project, and it is led by M2 Aero engines. And our part is the development of the motor and inverter. Yeah, and here we see our modular rotor with permanent magnets and our single tooth winding concept. And it is, then we see the high pole count motor and also the independent phase systems. So the system is redundant, and at the end also the stator, also water-cooled, fully water-cooled. And then we have our SiC-based inverter with a controlling unit for the multi-phase controlling and integrated in a modular design. And at the end, it will be plugged or connected to the multi-stack system of the hydrogen. Yes, here we can see. And yeah, as said before, this is a long-term project together with M2 area engines. These are some partners of us. So typically, most of them are universities or research institutes. And yeah, at the end, it would be great if you have any questions or further discussions. Come to our booth and we can discuss further your points. Okay, thank you.
Thank you very much, Petra. And our next speaker is again very different because they are well known as a helicopter manufacturer, but they lately also looked very much into electric. So David, I have heard with fascination really the product. I had a short look at the hydrogen project in Canada last year. You are working on electric with different manufacturers and cooperation partners. I just heard before the show that you now have a new partner for the battery system. So really interested to hear more about it because the electric helicopter is actually the original eVTOL because it's electric and VTOL. So at least it's the first one, and let's see how it can be in the competition with the newer generation.
Thanks. Apologize for my voice. I will try to still entertain. All right, so Robinson Helicopter Company has many world records in our aircraft for the AAM space. In particular, we've been working on electric aircraft since about 2016, so more than a decade now. And we'll talk about our 4th and 5th generation products a little bit in the presentation today, but I want to introduce the company a bit. So first, our business was founded in the 70s, and Frank, in 1976, the R22 was really his dream product. And so a lot of what I love coming to these shows is to see the future Frank Robinsons that are amongst us somewhere. Early in his career, I think people considered him to be a renegade, had ideas that others thought were crazy. So we're blessed to have his heritage in our business today. Ultimately, the product that he built, the R22, became a larger aircraft, the R44. And the R44 has been the backbone of the development of electric helicopters for that last decade. A big part of our strength is our factory, and we built a business that's the most vertically integrated of any that you're going to find here in the halls today at Aero. The video will run while I chat a bit, but a key part of it is fabrication of product it's achievable, it's scalable, it does take commitment, and you have to invest very much in people that can help run and master all of these trades to be successful. We're very proud that we can hire workers from our local area and develop their skills in advanced equipment, but in a lot of cases they come in with limited hand tool skills, limited knowledge of machining and welding, but ultimately they can build 30 and 40-year careers in our business that will be essential for the future of aviation. So all these products that you see around us that are at the early part of their development, there's a journey they're going to go through of how to make the product, and Robinson has been at the forefront of doing more of it internally. We buy raw material, we process it, fabricate components, and assemble them into the final aircraft. And we've got several aircraft on display in B5 if you have a chance to go visit. But ultimately, we're going to show that same value creation in the next generation of aviation as well. So we talk about our electric products. There are technologies that we're already going to be partnering with. You'll see batteries and motors are two groups that have a lot of investment going in. So we've got partners for each of our product in those spaces. Similarly, fuel cells for a hydrogen-powered aircraft has a partner today. And ultimately, for production, we may use the same partners or we may develop additional partners. And there is always the chance that we'll bring that in-house. And so many of our agreements with our collaborative partners include portions of manufacturing within the Robinson footprint. And you can see making aircraft has many, many steps. So if you haven't ever been to a factory like ours, come visit. It's really an educational tour. We love giving tours. And you'll see what I'm talking about. It's 1,250 employees, most of them in the manufacturing side. We've got about 120 people that are in the engineering, design, support, executive functions. Most of us make things every day, and it's really a marvelous change versus many of the other OEMs out in the world that typically are considered integrators, and they buy almost everything. We really go the other way with that. So our brand, one of the things that we're very proud of is that worldwide our product are used in some of the most difficult missions. If you've ever eaten tuna, steak, you drink wine, eat grapes, eat cherries, almost all of those require our aircraft, and there is not a substitute product for our aircraft in most of these markets. The R-44 in particular plays a huge role in many of those markets, but the R-22 is a big portion of what is used in the cattle mustering industry for Australian and South African beef. And it continues to be a big part of the training industry that backs all of the helicopter market around the world. Before long, we hope to also take on a larger role in military training. We're doing a lot of work to build out military training aircraft built on our turbine product, the R-66. So our full portfolio includes the manned aircraft that are on the top portion of the chart, but as well, this year we actually unveiled Robinson Unmanned. So a new portion of what we see as the future of AAM is unmanned aerial systems, including the former Ascent Aero Systems company that we acquired in 2024. They make the smaller drones on the left side of the chart. That team has been fully converted into the Robinson Unmanned business unit. They're coupled with product that have been in development for several years on larger unmanned helicopters like the R-44 Air Truck, R-44 Sprayhawk, and R-66 Turbine Truck. Each of those has a different end use, oftentimes cargo, sometimes specialty things like spray. Firefighting is an increasingly interesting mission for unmanned force multiplication. We still see a significant amount of the missions conducted with pilots. It's a huge part of how we look at the era of both, is the words we use to teach folks that ultimately people think this is kind of a war between manned and unmanned assets. We see it very differently. Our vision for the future is that there are too many needs for the number of pilots that we currently have in the world. There's so many opportunities to increase what particularly vertical lift can offer, and there's just not enough production to support that. So our goal with the Robinson Unmanned division is to present a hopeful future for pilots and businesses today that feature some portion of drones, some portion of piloted aircraft, and we'll be at the forefront of that. So these aircraft are all in varying stages of delivering. The R-66 Turbine Truck is going to a U.S. government customer over the next 3 weeks. The Air Truck and Sprayhawk have a number of customers. They've been delivered in a couple cases, actually for unusual development, things like target practice, where some of the advanced detection systems needed in the world need an agile, nimble VTOL aircraft to properly target and sight them. So they use the R-44 Air Truck as a targetable drone, as it were. And then our Robinson Unmanned smaller UAS are being delivered in all kinds of applications, from camera ISR to missions that would include communications relays. There's even some that are being used in small cargo, so grocery delivery and the like. Their strength is they are built like a helicopter, so they have swash plate-based controls that give them extremely strong wind tolerance, very good environmental hardening, so they're stronger than most of the quad rotors that you see out in the world and are ultimately higher performance as a result. So one of the topics we want to talk about today most was the hydrogen program. Yesterday we spoke a little bit about electric. I'll touch on that briefly. We are building our 4th generation of electric helicopter right now. It's our first that'll be an R66 built platform, and it features 2 major partners we've announced. MagniX for the motors. Their Hellastorm is an extremely power-dense product. You're going to see a picture of it in a minute. It's also featured on the hydrogen aircraft. And Cooler is helping us build the batteries. My vision for batteries is, unfortunately, they're too complex today at the pack level. Most of what you find, the packs and modules are going to be the most complex system on any aircraft in the event today. That's an environment that I don't think is scalable. We're going to work very hard to try to work with partners that can make batteries that are simpler, more robust, have less failures that ultimately will lead to nuisance failures or dispatch failures. Those things we think are going to limit the success of the electric adoption in the world. So our hope is that with partners like Cooler, we'll be able to circle the kind of major challenging parameters of durability and cycles, the ability for it to carry a proper energy density that's scalable for our product, and then finally, is it an affordable solution that has the simplicity that our products are known for. I definitely, as a Robinson product, are the most simple helicopter in the world. We cannot add the most complex thing with a battery that has thousands of sensors and many things that are creating nuisance alerts. So hydrogen. We have been working on hydrogen for several years. We announced it, I think, last year, and the aircraft's been flying for a full year now. So we've been using an R44 as the initial platform. That's really to prove out the fuel cells and the architecture of balance between fuel cells and the full electric batteries that are for surge and transient power. All of that has been performing very well. There's been adjustments to the system, but after a very short period where we had issues with the air quality and the humidity going into the cells, we've now been running pretty much failure-free or incident-free on the aircraft, and they've been doing up and away flying the last couple of weeks. Super excited. Sometime very soon the videos will be released from that, so you'll see that. Instead, I'll show you a couple things, videos of the aircraft in hover flight that gives you some good sense of how it performs, and show you some of the gauging so you can see how the power is distributed across the fuel cells and the battery. Our partner on this is United Therapeutics. They've been the pioneer, really, for all of this. They've been driving behind the scenes nearly all of the electric aviation advancements. Companies like Beta, they were early investors in. They've worked with us really since 2016 to develop this electric VTOL capability that they need for organ transplant. They produce genetically modified organs that are extremely sensitive to air quality, and so they want to make sure they deliver those with a zero emissions product from the beginning. This is a good shot from the top. I just like to highlight the 2 giant cans that look like turbofan engines are actually nacelles that contain cooling fans with lots of heat exchanger elements in them. One of the biggest challenges about the hydrogen fuel cell current state of technology is the relatively low temperature that they can live at and still be efficient. So we have a lot, particularly in helicopters where you're staying in a hover position for a long time, high power draw there. The thermal loads are pretty high. So this design has worked in our test facility in Montreal. Not sure it'll work yet in Arizona or places in the sort of more equatorial regions. But it is something that's telling us that there needs to be improvement in fuel cell tolerance. So mid-temperature or high-temperature fuel cells are going to be very important for that. And ultimately, it does give us a sense that this is a solvable technical problem. If thermal is our only problem, we can solve this. But it's going to require new investments in materials, technology, and innovative ways to get the airflow you need. So this will play, you can see the aircraft hovering. It's also very quiet. So one of the things that we like to highlight on this is that the frequencies of the rotor are actually very, very low, 400 RPM roughly. So that's a sound that a lot of us generally find soothing versus the high frequency sounds of higher, smaller diameter, fixed pitch props. Many of the drones, for example, have that tone that you hear. You can pick it out. Flies over your neighborhood, or if you're at a beach and you hear it, you know it's in the sky above you. Helicopters are quite different with the low frequency that they produce. When you take the piston or the turbine out, that drops out a lot of the high frequency noise. You're left with the tail rotor. So one of our focus areas for this next generation is to improve the noise signature of the tail rotors. But we feel like even just removing the power plant noise is substantial in reducing what people hear as the aircraft flies over. So we're excited about that. You can see some of the imagery in the loads. So the 2 fuel cells there, both are 85 kilowatt capable, but there's a balancing between those and the battery cell for transient loads, because the fuel cells are not as responsive as what you would find, say, in a piston engine like this aircraft has. Now that product is an R44. The R66 is being modified this year, and the expectation is that we'll have sometime in 27, we'll have ground runs in flight. It'll be a very similar stack, with the only major difference: this used a gaseous hydrogen containment system, which obviously has drawbacks in density and total performance. The liquid version, which has some other drawbacks in terms of the requirement to refrigerate it, that is going to be installed on this aircraft. And so we're excited when we get to that point. We believe this can fly 200 nautical miles, 0 emissions, producing just water. So the exciting part is we've seen this work. This is technically a feasible design, and now just needs to go through the rigor of a certification program. So you can see Transport Canada is the certification authority for this. They've already gone through a lot of their change product rule assessments, which allow for this to be a supplemental type cert under Transport Canada's approval. So our goal is, into this decade, that we can have a product that produces these technologies and available for the market. Obviously, there's challenges of infrastructure, going to be some challenges that are handling and ground support differences. All those things are being worked in parallel to this, but we're confident this is one of the few solutions that seems to circle all of the needs, provided that we can get some of the capability certified through the regulatory authorities. So we're excited about this as a potential future for zero emissions aircraft. And that's it for me.
Thank you, David. And just have a seat here. I think we don't need this one anymore. There is another microphone here. Can you check if it's switched on? Because seems to be yes. Okay, so if any of you have a question, you can lift your hand and ask. I have several. First one would be like to David, like we had here at the show, an electric flight show several times. We had the Siemens electric aerobatic aircraft flying here years ago. Is there a chance that we can have a Robinson electric or hybrid electric aircraft flying here next year?
Next year would be pretty quick, because we're going to be doing a lot of certification activity then, but it's possible. We definitely are working on projects that start, I think, in 2028, Tuan, for the Danish one. There's several programs that are funded by governments in the European Union that would support us progressing quickly a demonstrator product over here. There's a lot of involvement of European countries, companies that are here on our platform already, and so we're excited that that's a potential future over the next year or two.
Okay, next question would be to Emosys. Do you already have aircraft or electric aircraft flying with you, or you have project where they plan to fly in, and when can you, if not flying yet, when can we see them in the air?
Yes, thank you. It's a good question, because today we are not in the sky with our motor, with our electric motor, but we have concrete plans. But to be honest, we see next year the first fly with our motors as a prototype, but with a certified fly, maybe 3-4 years, not earlier.
Okay, question to Christian from Red Air Aviation Engines. Do you have already one of the hybrid units in use, or is it on the test bench, and when will it fly first, and will it fly first on a fixed wing or on a VTOL?
Yes, it's on the test bench, but I cannot tell you yet when it will fly, is the honest answer. So we need to wait for the announcement of the customer. So, sorry.
Okay.
We are keen. I mean, our engines are made to fly.
Okay. Yes. A question to Mitch on the propellers, because you said that you have also whirlwind propellers, which so when you but you with for the Rotex 916, the newest is a Hartzell which you have. So will there be also whirlwind propellers, and also for the on the electric side, or would you say all the electric side you will cover with Hartzell?
That's a great question. I see it coming from both sides. I think both Whirlwind and Hartzell propeller will be able to produce for the different solutions within electric. So, in fact, we have a partnership with Airmaster already with the Whirlwind side, where we supply blades into their hubs and their operating systems. And so the next step would just be to complete some of those ourselves, and then look at the aircraft that require the different requirements, you know.
But could it generally be said Whirlwind is the lower end, and then when it goes to larger aircraft, it's Hartzell, or it's kind of mixed?
It's a good way of looking at it, but the easiest way is that nothing in Whirlwind will ever go beyond ASTM.
Okay.
It never gets to full certification. Hartzell is always built for certification in mind.
So for, because big subject is Mosaic, we will have more on this at. So will there be, so Mosaic will then have both props in.
Both Hartzell and Whirlwind will go towards Mosaic. Yes.
Okay.
Yeah, good topic.
Next question to David. What about, a lot of people are scaling up. You're also scaling up with the power units. Are you also thinking of having a smaller unit, or is the existing smallest unit your smallest unit you have?
Of course, we're always looking at what the market is asking for, and there are different segments that are very interested in larger sizes and smaller sizes as well. Yeah. So I'd say we're always looking at that at this point. You can't expect in the future we will have a broader range of power plants, but nothing to announce right now.
Okay, and then a question to the batteries. Where do we, can we expect the first V4 Smart batteries in the air? You already have customers which are working to install it in the system, and if so, you can announce where, or if not, at least Germany or somewhere else.
Thank you for the questions. So we have a lot of customers which are not in series production now, but in pre-series or prototyping stage, where we deliver samples of different kind of cells. The applications are most of the time UAVs and eVTOLs, but we cannot name them. But they are in Europe, but also in the US.
Another question there, which would be probably for the manufacturer the most important one, or one of the most important one. People would consider that price-wise, if you compare, most of the cells are now coming from Korea and China. Even if you look into European cars, even if you look into Tesla, the cells are mainly made in China. CATL is by far the largest battery manufacturer in this area. So will you be competitor price-wise, or will it be a German top for the price?
Pricing, I think, is tough.
If you can take the microphone a bit closer.
The pricing is tough for sure, but based on the fact that we are focusing on really special applications, and therefore the volumes are also slightly lower. We don't have the big economies of scale, and therefore the cost comparison is not really valid. But in terms of power and performance, I think we are really on the top, and this leads to other advantages, like you can reduce the size of the battery pack because you need a lower number of cells, for example, and this at the end have also some benefits in terms of cost on the end application.
Okay, I have another question to Mitch. On the propeller side, as you said, you have Tanis for the heating side in the business. I think, or I've heard, there have been very often discussions because if you want to use eVTOLs for commercial transport, and like one of the first routes they are talking about is New York, you would use some de-icing system probably if you don't want to only fly on sunny days.
Yeah. Yeah, so, but for Tannis, that's mostly preheating your equipment and everything inside. We do build de-ice systems, though, for all of our propellers. So each propeller can be configured in a variety of different ways, with whether it be counterweights, feathering, windmilling, all of the different options that you're looking for, reversing. But ultimately, everything that we do has the ability for de-ice boots on your propeller itself.
De-ice boots normally used to have a hydraulic system, right?
Yes, correct.
So is there also, because I would expect, like, if you think very often you do heating with electric, is there also some systems on the way already with?
Yes, we do have that as well. So we can plug the de-ice boots directly into an electric feed and just feed through the power the engine is producing.
Yeah, but no, I thought maybe heating the blades with electric.
Oh. We're not there yet. I like where your head's at, though, Willie.
Okay. Next question would be, Christian, you said that the red aircraft is used or will be maybe used as a APU unit and in large aircraft, replacing a turbine. Is this not a question of size, where in the aircraft would be, because normally you think if I look at a BT6 size, it's slightly smaller. So would your aircraft fit in an airliner easily?
So we cannot. We are targeting all the APUs from whatever business jet. I mentioned we are targeting also smaller versions down to 140 kilowatt electric power output. So I would say yes. Depends, of course, on the mission profile, if it makes sense. You have to have a certain mission to have the full advantage of the half of the fuel consumption. So I would say in general yes, but we need to look in specific which aircraft can it fit. But we're targeting from small to large aircraft, yeah.
Okay. Question to David, because I read some comments on you, or if you discuss the helicopter with electric motor is the most original or oldest eVTOL you can think of. Unluckily, I can't have you in my eVTOL panel later this afternoon, so I ask the question now. What do you think competition of an ER66 compared with one of the existing eVTOLs?
Well, for those who follow me online, that's probably not a surprise, but ultimately, these aircraft are going to have to hover. And if you're going to hover, the power requirements of a wing-based or multi-rotor design tend to be so extreme that the battery will undergo a lot of damage, even just in that short, brief period of hover. And then you'll go on a wing for a period of time, ultimately returning to hover before you land. That mission is what we do every day, just all on one highly efficient, large disk. We believe that flat power curve that results from that helicopter architecture is a key enabler of the durability of batteries and the ability to use lower power C-rated batteries. And we think that's going to be the thing that unlocks scalability in this market. And I think when people really do pencil in this work, most of the people who are in this space, the reason why there's so many people in the eVTOL industry that are leaving and working for Robinson and leaving and working for our competitors in the helicopter space is because they see this. Ultimately, there is a real flaw, and it's partially the reason why they're going to hybrids as well. All these signs indicate what we've known for a really long time, is that a pure electric version that is driving so much power draw in a very transient, short period is a very inefficient design, and one that's going to destroy the economics and the scalability of the product. So we believe, based on our proven history now with record-setting, long-duration, multi-crew flights for our ER44, we know that this product works. There's still limitations on a pure electric architecture. That's why we have the hydrogen solution. I think what we're going to see is the economics and the scalability of it are significant. The other piece that I think gets washed out in a lot of discussion, but is really important. It doesn't help to have a lot of different ways aircraft are operated in a commercial application. If you got something where you're flying and they're flying 3 different eVTOLs, which all have different control architectures, different aircraft responses, different inertias in the aircraft, that system design can be extremely unsafe for standardization of pilots. For us, we know that over the next 50 years, we're going to go through a journey of jet fuel and gas-powered aircraft all the way to pure electric and maybe hydrogen as well. For those, commonality of controls architecture, commonality of maintenance and systems architecture on the maintenance side is going to unlock a really significant enabler, which is safe operation. And that, I think, is going to be a mortal wound when one of these aircraft has a mishap and it's traced to, well, he was flying this aircraft on Monday and on Friday he was flying a different aircraft and he was confused about the way the indications for state of charge or for how the controls modes are enunciated. All those things are significant, real problems that are being faced by individual companies right now, but ultimately the operators are going to have to mesh all of that and operate conventional fixed wing, conventional rotary wing, and these novel architectures, and I think it's going to result in some safety operations that are less than ideal. So, yeah.
I would have a quick follow-up on you there, because like when you talked about operations, and I've flown some of the simulators of the eVTOL side, which seem to be quite easy to fly because the computer is doing a lot of stuff. Flying a conventional helicopter, it still demands a lot of knowledge of the pilot. So are you also working on getting helicopter flying more easy, which would also be easier to solve the pilot problem then?
Yes, I mean we've got customers that are doing significant fly-by-wire integrations on our aircraft. There's a real difficult trade of cost and weight of fly-by-wire in a light helicopter. What I think you're going to find in the evolving eVTOL story is these are 6,000, 7,000, 8,000 pound aircraft. They are highly, they're fighting gravity in a way that's much more challenging than a helicopter can afford. So yes, we are improving the human interface on our aircraft through things like advanced autopilots, multi-axis autopilots that make flying an easier experience for those that maybe are less frequently in the cockpit. But we don't get routine issues, and when we study accidents, they're not accidents that occur because someone's not able to handle the workload of the manipulating controls or even reading the instruments. Most of the challenges we have is aviation decision making at a level just below that is departing into weather or not properly forecasting what's at risk in an en route weather change, management of power, which is a more complex topic of math, not necessarily one of the actual manipulation of controls. So I think those are the things that in a simulator you get into for an eVTOL. They're presenting what is a marketing demonstration, flying it in a benign environment. Have them turn the wind up, have them put the gross weight up, have them fail a motor for you. They won't do that, but ultimately those are the scenarios that a real operation has to manage and is going to happen on a statistical basis that's much higher than what's acknowledged. The failure rate of every motor on that ship, and I buy motors just like that for my drones, is very high. And ultimately, that is going to be something that you have to learn how to fly when one fails, then when the second one fails, when you shut off the third to balance the overall torque. Those things are going to result in a significant, complex operating environment that's just not fully discussed today.
Okay, thank you. I think we are about to finish here, so thank you for being here. For the viewers, for the visitors, we have another panel today at 2 o'clock on eVTOL and another one at 12 o'clock tomorrow noon on fixed-wing electric aircraft. If you have any further question and want to get further information, I mentioned we have our magazines, where the eFlight Journal, where we cover all the electric stuff on a regular basis. And there will be other events featuring this. For example, in Oshkosh, the Electric Aircraft Symposium, they just partnered with eFlight Expo here at Aero. So if you by chance going to Oshkosh, you should come 2 days earlier and then maybe go to the Electric Aircraft Symposium where we'll get the follow-up. And last but not least, we have another event which we do in China, which is also on, it's called the eFlight Forum, for 10 years now in a row. And we'll also have some interesting stuff. And yesterday we've seen, especially from China, if it comes to AI integration into the cockpit, computer integration into operations, it's definitely worth going there and having a look at how everything is going there. So thank you very much, and see you hopefully at the next panel at 2 o'clock.